Hey guys, Mr. Yisley here. So we are on to lesson number 20, which is all about evaluating a numerical expression using the difference of two squares. And so the reason that we're talking about this is sometimes we're going to get problems in math like this, where we have 54 squared minus 48 squared. Now, if you're anything like me, you don't know what 54 squared is, and that would take a lot of work to get there. Same with 48. All right, and we may not have a calculator available, as we don't use them very often in this classroom, or you may not even have one on you. So in this case, what we do is we use the information that we learned about a difference of two squares, because again, we can identify this two terms, subtraction symbol in between, both are perfect squares. That's obvious by that. So what we can actually do is we can break these apart, right, into a difference of two squares. So factor them out. So first, we've got to have two parentheses with a plus in between and a subtraction in between on the second one. Then we're going to put the first term for the first term of each one. And then we're going to put the second term for the second term of each one. Now you may be saying, well, why would I do that, right? Well, because once they're in that form, we can simplify them down, and then we're going to end up with a little bit smaller numbers that might be easier to work with. So 54 plus 48, right, that is 102. If you're not sure, again, you could work that out, but I can do that one in my head because I know 50 plus 40 is 90, and 8 plus 4 is 12, and 90 plus 12 is 102. Then the second one, we've got 54 minus 48. Well, I know that that is 6. So now we've got one substantially smaller number. So then I could just do that basic multiplication to get my final answer. So 6 times 102. Well, 6 times 2 is 12. So bring the 2 down, carry the 1. 6 times 0 is 0 plus the 1 is 12. And then 6 times 1 is 6. So 612. And there we go, we've got our final answer, all by using the difference of two squares. And so this allows us to, again, use the factor pairs that factors that we've learned of difference of two squares to work with a little bit smaller numbers. Because 54 times 54 is going to be a really big number, I know, and 48 times 48 would be a really big number. So rather than worrying about that, I just broke it down and got to deal with a little bit smaller numbers that were a little easier for me to use. All right, well, let's take a look at example B. So I see with example B, I've got two terms again, separated by this subtraction symbol, right? Both of them are perfect squares because they already have the squared next to them, so that makes it obvious. So again, I'm going to break it apart into its factors. So first one's the plus, second one is the minus. First term of each one is 68, because that was 68 squared. Second term of each one is 62, because that was 62 squared. So then we do the math, right? Well, 68 plus 62, well, 60 plus 60 is 120. 8 plus 2 is 10. So 120 plus 10 is 130. So there's my first one. Second one, 68 minus 62, well, that is 6. So now I'm down to my two numbers that I can multiply. 6 times 130, well, 6 times 0 is 0. 6 times 3 is 18, so bring the 8 down, carry the 1, and 6 times 1 is 6, plus 1 is 7, so 780. Now again, if you're not sure what those things are, or you can't necessarily do those in your head, that's okay. I could write that out, 130 times 6, and I could do that. 6 times 0 is 0. 6 times 3 is 18, carry the 1. 6 times 1 is 6, plus 1 is 7. And that's okay, right? And it's a little bit easier than if we were to multiply 68 times 68. All right, well, I'd encourage you to try example C now on your own, then check your answer with mine. All right, well, again, I notice two numbers, right, with a subtraction symbol in between. Both are perfect squares, so I can go into my two factors here, which are plus and minus. My first term of each one is going to be the 47 that was being squared. My second term of each one is going to be the 44 that was being squared. And now we've got that. So 47 plus 44, Well, I know 40 plus 40 is 80, and then 7 plus 4 is 11, and 11 plus 80 is 91. Now again, you could always use the stack method and add down like you normally would. If you can't do it in your head, that's okay, or don't want to do it in your head. 47 minus 44, I know is 3. So I've got that one simplified down. So last step, multiply the two numbers. Well, 3 times 91. 3 times 1 is 3, and 3 times 9 is 27. So 273. All right, well, again, I'd encourage you to try example D on your own, then check your answer with mine. So example D here, I've got 28 squared minus 24 squared, two terms. Both are perfect squares separated by a subtraction symbol. So again, I can go into my difference of two squares. This one's a plus, this one's a minus. First term of each one's going to be the 28 here. Second term of each one's going to be the 24 here. 28 plus 24. Well, 20 plus 20 is 40. 8 plus 4 is 12. And 40 plus 12 is 52. 28 minus 24 is 4. So 4 times 52. Well, 4 times 2 is 8. And 4 times 5 is 20. So 208. All right, well, if you've got any additional questions on how to evaluate a numerical expression when using the difference of two squares, please let me know. Otherwise, you should have what you need to continue on to lesson number 21.